All right. Hi, Cameron. Hi, Notile. So welcome, everyone. We've just started the recording, and so we're doing our third lesson on analytical geometry, and we're just starting with a little warm-up for Maths 24. The numbers, in case you can't see them, are 6, 8, 2, and 4, and we try to make 24 with them. Seth has an interesting one. 6 times 2 plus 8 plus 4. I think you've got it, because that's 12, that's 20, that's 4. Seth, you are a Math 24 champion for the day. Well done. That was not an easy one.
Well done, Seth.
Well done. Okay, guys. So some other things. I just want to. We are running a exam preparation workshop this Saturday. From 3 to 4:30 p.m. And so far these students are on the list, the ones that you can see on the board. If you would like to join us, your parents have been sent an email. And the cost is 199 Rand for basically both these lessons together. So we're going to do 3 hours of basically just focused exam preparation. And we're probably going to do paper 1 the one week and paper 2 the other week. And so I just want to make sure that you're aware that you have been sent that information. And if you'd like to be in that session, look for that email from Watobe, and you need to sign up in the next 2 days, I think it was. Yolanda, can you remember anything else about that we need to tell the students?
So I just know that the list here that we have here is the students that already joined.
Yeah,
so
they've joined.
If you realize that your name is not here, so it might be worthwhile to just check with your parents and try to make sure that you join as soon as you can. Yeah.
So just to let you know, because we basically surveyed students and we found that they didn't just want content like we're doing, that they also wanted some specific exam preparation. And so we created these workshops because we know a lot of you are going into exams fairly soon and you might want a mixture of topics. Okay, the other thing is we're going to try something, couple of things that are new today. We're going to use a format called example problem pairs, and it's just a little experiment with a format that I think might work quite well for us, and so watch out for the example problem pairs as we go into the lesson. So the email should have been sent to all of your parents. If not, have a look at the Watobe website, but you should have got an email from us. Okay, let us get going with an overview of what we're going to do today, and then we'll start in a moment. So really, lesson 1 was the distance formula, the midpoint formula, the gradient formula. Ooh, gradient formula. Lesson 2 was all about straight lines and connecting back to lesson 1. And so I just want to start this lesson with a little bit of a review of that. And then in today, we're actually going to continue with straight lines, but we're going to focus on something called collinearity. And then we're also going to talk about something called intersection points. And then if there's a little bit more time, we'll carry on from there. But that's the main focus of today. So I want to start, let's do this, with these 2 questions. I'll move these to the side. So these are my 2 questions to get you going. And I want to see, can you do these by yourself? And I will give you, let's say it's now 1805. We'll go to 1809. And then once you've got, we'll call this question 1, we've got this question 2. And this is basically just checking, are you familiar? The second question is a little bit tricky. What have you remembered from the last lesson is basically what I'm checking. So over to you guys. And once you have got the answers, you can pop those answers in the chat. But I'm going to be quiet for a little bit unless there's a question. If there's a question, you can raise your hand and then I will do my best to help you. Okay, I see some answers already coming in. So in question 1, it says that we are looking to find the slope, and the slope is to do with the gradient. And the formula for the gradient, we often use the letter M. The main thing from the last lesson that we spent a lot of time was that the Y must be on top. Okay, so I see a lot of students are saying that D is the answer. And we'll see in a moment if you agree. If I agree, it does look to me like you're on the right track. I have been sneaky and done my working out earlier in the lesson, and the answer I get for D is I do get a half. And so
well done, guys. Good job.
Let's see if you can do. So for those who want to have a conversation about one, just raise your hand and we can chat. So what is the slope? The slope is another word for gradient. So slope is the same as gradient. And so that means the same thing. Now, the second question will take a little bit more time. And so I'm going to give you a bit more time. Oh, sorry, that's me. What can you do for the second question? So in order to find the equation, you are going to have to find, to start with, you're going to have to find the gradient between these 2 points to get you going. So if you're stuck, why don't you just start with that? Think, if I had to find the gradient between those 2 points, what would I get? Okay, so there's some answers coming in for that. Sepang, could you tell us, what did you get? Maybe you could just jump on the mic for a moment. What did you get for your gradient?
So I got -3/8 for my gradient.
-3/8. Okay, so we'll check that in a moment. Then hopefully that's the first step. And then what do you need to find? So basically all straight lines in the last lesson, all straight lines have that format. And so that's why I was kind of pushing you towards finding the gradient first. But then once you've got that, you then need to think about, okay, well, how do I find the C value? Okay, let's see if everybody else. So some people are saying it's C, some people are saying D. So that's good. There's going to be debate in the class. Okay, I said tools. It's got to 10 past. So let me show you my working, and then we can decide if we agree. So if you look, I start by figuring out my gradient, and I do agree that the gradient is -3/8. But then what I did was I took the -3/8. I should just make this a little bit bigger so you can all see it. So once I've got my -3/8, I put it into my mx plus c formula, and now I have to find the c value. And I need to choose a point. And of the 2 points, I chose the easy looking one, which is 5 and minus 8. And so you'll notice that I put where x is in the formula, I put a 5. And where y is in the formula, I put a minus 8. And that comes from, here's the x, and then here's the y. Then if I multiply that out, I get minus 15 over 8. And then I have to, if I move it across, I get plus. And so my answer is minus 49 over 8. And so minus 3 over 8x minus 49 over 8. And what one do I get for that? I get C. And so my answer was C over there. So I just want to get a feel for this. I might have been a little bit quick there. And so don't worry, you'll have plenty of chances to practice this throughout the module. But step 1 was, can I find the gradient? Step 2 was, can I sub a point in to find the equation of the straight line? And that's C. Notine, go ahead. I see your hand is up.
Sir, I wanted to ask if they have asked me a question to to find an equation using another type of style, not y is equals to mx plus c.
Yeah.
How am I going to do it?
Do
Like
that one.
this
Okay.
equation ax plus by plus c is equals to 0. How am I going to do that one?
Okay,
It's
perfect.
kind of
No, I know what you mean. It's called the alternative form. So let's
Yes.
take the answer like it is like this, and let me change it to the form that you're talking about. Now, in the form you're talking about, everything is on one side. And so what's going to happen is I'm going to take this bit here, and I'm going to move it across, and then I'm going to get positive 3 over 8x plus y. And then I'm going to move my minus 49 over 8. I'm also going to bring that across, and that's going to become plus 49 over 8. And all that's left on the right-hand side will be 0. And so what you were saying is I need it to be in the form of a number x plus a number y plus a number, or, you know, this is going to be your a value. Then hiding in front of y will be a 1, which will be your b value. And then the c value would be 49 over 8. So does that help you?
Yes, sir. Thank you.
Perfect. Nawazi, go ahead. I see your question is up. Your hand is up.
Sir, I wanted to ask from the part where you substituted negative 8 and 5 and how you
Perfect.
got negative, the part where you substituted like negative 8 and 5 and
Okay.
how you got the answer below.
Okay, let's go through that a bit more closely. So first of all, the first step is the substitution step. So notice how minus 8 is y, and so minus 8 rocks up on this side, and 5 rocks up on this side. So what is a little bit sneaky is that I'm thinking of 5 as 5 over 1. And so if you imagine what's minus 3 times 5, it's minus 15. And then what's 8 times 1, it's 8. So that was the step that I think a lot of people got caught up in. And then the other thing now is I need C to be by itself. And so if I've got minus 15 over 8 on this side, what if I bring this term over here, if I bring it across, it's going to become plus 15 over 8. And then at that point, I just use my calculator to add these two things together to get that. Okay, so does that help a little bit? Okay. I'm gonna, guys, what I'm gonna do is I'm gonna go on to the next type of question. But I do hope that yeah, this is just, we'll keep practicing this. If you haven't got it yet, don't stress, we'll just keep practicing it. But I want to start with a new idea called collinearity. And so what I've got on the board here is I've got an example on the left that I'm going to do now with you. And then on the right-hand side are two problems that you're going to work out after I've done the example. Okay. So what does it mean for something to be collinear? Well, if something is collinear, it means it's on the same straight line. So let's just make sure we see that word, collinear. If you imagine a straight line, if 3 points are collinear, these 3 points, A, B, and C, are collinear because they're on the same straight line. Whereas if I had a straight line and one of the points was here and 2 of them were on the line, this is not collinear. Okay, so that's what the word means, literally means on the same straight line. Now, if I want to check whether or not points are collinear, what I need to do is see that the gradient between the points is the same. So if something is collinear, the gradient from A to B will be the same as the gradient from B to C. Or it'll be the same as the gradient from A to C. Whereas if, guys, if I could ask you to put yourselves on mute if you are in the room for now. If you look at the one where the point is off the line, the gradient between the first 2 points is different than the gradient between the second 2 points. Okay, so that's the main idea if you want to check for collinearity. So how does it actually work in practice? Well, I'm going to work out the gradient for DE, and I'm also going to work out the gradient between E and F. Okay, so what I have here is I have that, and I start by working out my gradient. So DE, I'm going to start here and go 5 minus 3. And then for this one, it's going to be minus 3 minus 1, which in the end is going to give me 2 over minus 4, as long as I'm being, or minus a half. Now, what is the gradient for EF? Well, the gradient for EF is going to be look slightly different. I'm going to go 7 minus 5. Let's get rid of this bit. So 7 minus 5. Notice how I do my y's first, and then minus 7 minus minus 3, which then gives me 7 minus 5 is 2, and then minus 7 minus minus 3 is a bit tricky because minus and minus is a plus. So minus 7 plus 3 is minus 4, which is minus a half. Now, what has happened is that the gradient between each of the points is the same. And so therefore we can say that therefore D, E, and F are collinear. Did you get a different value for DE? Let's just check. 5 minus 3 minus 3 minus 1. No, I'm pretty convinced of that. Okay, guys. So what I want you to do now is I'm going to give you about 4 minutes, and you are going to try by yourself to do the 2 questions to see, is A, B, and C collinear, and is K, L, and M collinear? And I want you to use the same sort of method as I did now. Okay, over to you guys. And if you have a difficulty with this question, I'll have a conversation with you while you work on that. Okay, so just raise your hand and I can take, I'll unmute you. Okay. But the rest of us, let's see, is A, B, and C collinear? Is K, L, and M collinear? Oh, sorry, I raised that out of. Yolanda, can you see okay? Is it clear enough to you, the question?
Yes, it is clear. And I already see some answers. Germani said something there also on the chat. She gave some answers.
So yeah, let's pop our answers. They are both collinear. I don't know if I agree with that. That was very quick. So what you want to do is you want to work out the gradient between A and B and the gradient between B and C, and then do this and just see, because I'm not 100%. I think some of them might be collinear. Will they ever ask us if they aren't collinear? They could ask you, but they normally ask you if they are collinear. But basically what you do is you check the gradient between the points, And if the gradients are the same, it means they're on the same straight line. If the gradients are different, it means they don't all fit on a straight line. I'm going to wait a little bit longer because I think most students are still busy working this out. It's quite a lot of working. What I would do is I would just start by setting it up. Like, what is the gradient of AB? What is the gradient of BC? I'd structure it nicely like that. You can't see? I can try and zoom in a little bit if that would be helpful. Let's get rid of some of this stuff. How's that? So pop your answer in the chat when you've got it. I'm just giving a bit more time for all students. And remember, there is a second question as well. Hey? So there's the ABC question, and then there's the KLM question. So for the very first question, they are collinear. So I agree with you that the first one, it is collinear. Now, what about the second one? You're right. So the second one is also collinear, and both of your gradients should be -1. I feel like I've got one more question on this in me. So let's, can you do this one? 2.1.3. Are those points collinear? I want you to work out and put your answer in the chat. Well done, guys. Well done. That was impressive.
We can do this.
Yeah, we can do it. I always find if you set these questions up in the right way, half the battle is just setting it up so that you have a clear idea of how to work it out. And that's hopefully what students will get.
Yeah,
So,
it does help.
So this is our last one on collinearity. And it's just this basic idea that, and you do see these questions come up in exams. So Dawn has put her answer, Notila has put their answer, Tracy has put her answer in the chat. Let's just give a little bit more time. One of the things I've been doing this already, but I really like when students make sure they start with the Y's. So because the Y must go on top, and then you do the X second.
It helps not to do the silly mistakes that I normally do. So I'm following your examples.
Exactly. So what we get for the third question is the one gradient is going to be a half, and the other gradient is going to be -1. And so when we have that situation, we would say that P, Q, and R are not collinear. So basically, if you imagine a straight line, we aren't going to be able to fit all 3 points on a straight line. Only 2 of these would be on a straight line. And then, essentially, there's no way we could make them all go through the same straight line. Okay, guys, that was pretty good from what I saw in the chat. Let's have a quick little vote. Thumbs up if you feel comfortable with this concept. Thumbs down if you still feel unsure. Just so I get a feel for the group and where you're at. Okay. I think All right. So again, it's not to say that you have to get it completely. You just have to get most of the central ideas. And then you go back and practice some more over the weekend. Okay, so let's move on then. I want to do a little multiple choice question. And I want you to say, which diagram could the following equation represent? So I want you to try and see which graph do you think will match the equation y equals 2x plus 1? And I want you to put that in the chat. Okay, there's a couple of different answers. I like it. There's a lot of A and there's a lot of C. And I like a bit of debate, which is fantastic. So what will we need to know in order to help us? Because this goes to the equation of a straight line. So in a straight line, this number tells us something. This tells us the gradient. So the gradient is 2, and the gradient is positive. And then this number over here is the y-intercept. And that's also positive. So we're looking for a graph that cuts the y-axis in a positive place and also has a positive gradient. Now, I can see that has a positive gradient. I can see that has a positive gradient. This has a negative gradient, so I'm going to ignore it, and I ignore that. Of these two choices, which has a positive y-intercept? A y-intercept is where the graph cuts the y-axis. For me, that looks positive. It's above the x-axis. This looks negative. So I'm going to reject that one. And so the answer would be A. All right.
Well done, guys.
So I like these questions because they just force us to think a little bit about when we're figuring out the formula, but now what happens if we have to see the graph? Do we know what it means? Because remember earlier on in the lesson, I was like giving you 2 points and then you had to work out the equation of the graph. But sometimes they give you a picture of the graph and you have to be able to connect that to the equation. All right. So I hope that was helpful. Let's do one more of these before we take a little break. So I'll read this through with you first and then you can vote. So it says, Tom and Katie are arguing about the equation of the line. And Tom says the equation of the line is y equals 2 minus x. And Katie says the equation of the line is x plus y equals 2. Who is correct? And I want you to look at A, B, C, and D and decide who do you think is correct? Well, let's have a look at this graph first. If I had to work out the equation of this graph, I suppose I should try and work it out first. So to me, its y-intercept I can see is 2. So I know there's going to be a plus 2 on the end here. And then what is the gradient going to be in front of this? To me, it looks like a negative gradient. And it looks like it's going down. So it basically goes, if it goes down by 1, it goes across by 1. So it says to me that the equation of this graph is negative 1x plus 2, which is the same as this one over here. Okay. But there's a catch, guys. There's a catch. Sneaky, sneaky. Remember earlier in the lesson, I was asked about the alternative form of a straight line. If you take the one that I've underlined in blue, if you move the x across to the other side, if you moved this x to the other side, what would you get? You'd then get x plus y equals 2, which is exactly the same as what Katie's one is. Which that actually means that these two graphs are the same graph. They're just written in slightly different ways. Now, I worked out the equation of my straight line was minus 1x plus 2, or again, written slightly differently, I could write this as 2 minus x. So they're both correct is the honest answer. And so the answer is going to be C. So just bear in mind that the goal of this multiple choice question is to show you that straight lines can sometimes be written in different ways. And so be aware of that. You know, it's not a problem if you said B is the answer, but just be aware that sometimes straight lines can be written in alternative ways. Okay, I think we have earned a break. And so what I want to do for the break is I want us all to stand up, please. So stand up and just step away from your table for a second. And what we're going to do is one of my old favorites, which is a pen flip. And so what I want you to do is I want you to take a pen in one hand. I'm just getting something. And so I want you to try and toss it, but let me actually demonstrate, because I think, so stand up where you are.
Come, Bali, I see you, stand up. Bali Mango, I see you, let's stand up. Thank you.
So what you're going to do is you're just going to try and toss this pen so it spins once, and you catch it the same end that you're tossing it. Oh, it spun way too many times. So see if you can toss it so that you catch it the same end. Okay, I didn't quite get it. See if you can do that. Almost.
Woo, I got it, guys. Let's go.
And then if you can do that easily, and I'm sure you can't because this is flipping hard. Oh, there, I did it. Yeah. Is you can just try this activity on your left hand. So try it on your opposite hand. See if you can spin it so that it only spins once and you catch it on the other end.
Wow, on my left one is difficult.
Yeah, the left hand is much harder. See if you can do that. And then what I'm going to do is I'm also going to put something else up for another part of the brain break that I think you will enjoy.
I see you, Bali. I see you. You're doing it.
Well done. Yes, practice makes perfect.
Yeah.
All right. Then for the second part of our brain break, I want to see, can you solve this puzzle? So I've put a number puzzle, and the goal is to solve this thing at the bottom. And I want to see, can you solve this puzzle? What is a yellow flower plus a blue flower times a red flower? I'd love to see if anyone can get this. And I'm not going to say too much while you attempt these. Okay, so Seth has an answer that's come in, a couple of different answers. So think about, what does the red flower have to be? What does the blue flower have to be? So David, you're right. I agree with you. I think, David, you got the red flower sorted. But now what about, remember, the goal is to figure out the last line, which is a yellow flower plus a blue flower plus times a red flower. Oh, I see a couple of people are getting it. Well done, guys. So I think that that's 20. So then what is blue going to be? Blue has to be 5, which means yellow has to be 2. And then because of BODMAS, 5 times 20 is 100. Oh, you can't even see me in the, and then that's, so the final answer should be 102. So well done. I see lots of you got that right. Sihau, and I see Elisa, Kozi, Yanga, Aseri, Madibane, Nomfa. You all did very well. Watch out, it's not 100, it's 102. 102. Okay, so that was our little brain break for today. I hope that you enjoyed it. I want to now move on to the last part of the lesson. So I want to talk about intersection points. And on the screen, what I have is an example that I'm going to do for you, and then you are going to go ahead and find the answer for me and write the chat in. Okay, so basically, here's my example. Often you're given equations, like you're given a drawing like this, and you have to, there'll be a label. And so these two straight lines are intersecting and meeting. And so if they say to you, normally they'll either say solve the equation simultaneously, or they'll ask you, they'll say, what are the intersection points of these two straight lines? And literally what the intersection point is, it's where the two lines meet. And so if I look at this question, the x coordinate of the intersection point is 2, and the y coordinate is going to be -3. And so we would say the intersection point is 2 minus 3. Now, what's even more impressive about the intersection point is that if we sub it into both these equations, it makes them true. So watch this. If I take y equals minus x minus 1, I suppose I should just put the x in there. So that was the one equation. If I take my point and I sub it in, you will notice that I get -2 minus 1 and then -3. Notice how when I sub that point into the straight line equation, it makes a true statement. Okay, and so if I had to do it with the other straight line, let's just see that it does work as well. So I'm going to take my 2 and put it where the x is. And if I put the -3 on this side, does it work out? So -4 plus 1, does it equal -3? It does. Okay. Now, you don't have to do the extra on the side. You just have to know what is you have to be able to recognize what the intersection point is, which in this case was 2 minus 3. Okay, so I want you to look at this drawing, and I want you to tell me in the chat, what is the intersection point for these two straight lines? And I want you to write it in the chat. Okay, so look carefully at the drawing. Where is it? Okay, so clearly this is -2 and this is -3. And so my intersection point is going to be -2 minus 3. And if I wrote it out in correct form, just like that. Perfect. Okay, what about this? What is the intersection point going to be of these two lines? Aha. So I see there are a couple of answers coming through here. What is the intersection point of these two lines? So you can see graphically that these two lines never ever cut each other. And so there is no intersection point. So there can sometimes be occasions where two lines do not intersect. Okay, Lorraine, you stole you're absolutely correct. The reason they don't intersect is that their gradients are the same. They're parallel to each other. Look at how the gradient here is 2 and the gradient here is 2. So whenever two lines are parallel to each other, they're not going to have any intersection points. Okay, so that's an important idea. Well done. Amachli, go ahead. I see your hand is raised. Go ahead, Amakle. Okay. All right. Well, then, while we wait for that, okay. So you've got intersection points of that. Apelele, go ahead. Ask a question. Yeah.
Sorry, sir. I just wanted to ask if we get asked a question like this, will we have to do any working out to prove that
Okay.
there's no intersection?
So we're gonna do that now. I was just showing you the graphical scenario first. Sometimes, so in this case, if they give you the drawing, you would say, so what's the working out? You would say the two lines are parallel because they have the same gradients. So you could say the lines are parallel because both have a gradient of 2. But this is not a typical exam question as it is now. I'm just basically teaching you the idea. Let's look at a more typical exam question over here in the next one. So sometimes we have to find the intersection points algebraically. So maybe I give you these two equations. And what I'm going to do is I'm going to do an example for you now, and then you'll do it by yourself. If you look at these two equations, these are straight lines. And if I say to you, solve them simultaneously or find me the intersection points, what do you do then? And that's what I'm going to show you now, what you need to do. So what you would normally do is you would solve them by solving them simultaneously or substituting into them simultaneously. So you'll see that in this first question here, you've got y equals something. And then the other question, you've also got y equals something. And so what we do is we substitute, say, the first one into the second one. And we write minus 2x plus 1, which is this equation. And we sub it into this one. And we end up getting this situation. So this is a very important step because this is called substituting, and it eliminates one of the variables. The variable that I've eliminated is y. And I want to get a quick vote from the class if you understand what I've done there. Because if you haven't understood this, I need to slow down and try and explain it a bit more clearly. So give me a thumbs up if you get what I've done. Thumbs down. Okay. All right. So whenever you are solving for a simultaneous solution of two straight lines, or if they say to you, find the intersection points of these two lines, there are different techniques you can use. And the one technique that I would recommend is substitution, where you substitute, you talk about, say, equation 1 and equation 2. And I'm going to substitute equation 1 into equation 2. And so the way I would do this is I would actually write equation 2 with a big open space where I'm going to substitute into it. So this is equation 2, except I've left out the y. And instead of putting the y in there, I'm going to take equation 1's y and substitute that in. So I get minus 2x plus 1. Now the brackets aren't really necessary. I'm just showing you something. Now the good news is that this equation only has one variable. And so I can try and solve it. So how am I going to try and solve it? Okay. I'm simply going to move my x's from this side. I'm going to add 2x to both sides. If I add 2x to both sides, it looks like this. And so I get 1 equals minus x. I'll put the 2x next to this minus 1. And what's more, I can get 1 equals x minus 1. So notice how the minus x plus 2x just gives me this. Then I've got this problem over here. Got this problem over here. And so what I need to do now is I need to add 1 to both sides. So I'm going to add 1 here, add 1 there, and then I get x is 2. So one of my solutions, or one of my intersection points, I've already got. It's going to just be x is 2. But the problem is, I don't just need x is 2. I need to know what is the y coordinate. And so I need to do an extra step. I need to use one of the original equations to find what y is. And what I do is I simply choose the easier of the two. So of these two, the one that looks easiest to me, but I could have chosen either, is this one over here. And so what I'm going to do is I'm going to substitute in that 2 into that equation. So I go y equals minus. So can you all see that this equation is the one over here? And I'm going to sub my value 2 into that equation. And now I go y equals, now what's minus 2 take away 1? It's minus 3. And so my answer is going to be 2 minus 3. This is the intersection point of these two lines. So that is my example. I want you to try and practice that, but I want you to try and practice it using this example over here. And I'm going to give you one tip. I'm going to say, work with the easier of the two equations. So at the moment, this one to me looks more complicated than this one over here. And so I'm going to say you need to work with this one and substitute it into that one over there. And I want to see, can you simultaneously solve this? I'll give you a little bit of time to work by yourself, and then I'll start giving little tips as we go. So Nawazi's question is, are intersection points always solved with simultaneous equations? Yes, Nawazi, they are. And because it's actually, I know that this is the first time, I'm going to give you this little tip. I'm going to say, look, this is equation 1. This is equation 2. I want to sub equation 1 into equation 2. The problem is, how do I do it? Because they're not as nicely set up as last time. Last time it was easy. Why was it by itself? So if I do this, if I move this equation, if I work with it a little bit, I can write this equation as y equals minus x plus 8. Now that's the same equation, but I've just rearranged it so that it's in the form y equals, it's like what we call standard form. Now, can you use this to help you find, I want you to find the intersection points of these two straight lines, but I want you to try and use the method I was using. Okay. Lorato, where am I? Okay, let me guide you in this process. Let's do another example together, then I'll give you one last to finish the lesson. So this step over here, we had to change the form of this straight line equation. I need to sub it into equation 2. And so what I'm going to do is I'm going to write equation 2, and I'm going to leave a big space where I'm going to sub in. Now, what I then need to do is what goes in the space? It's going to be minus x plus 8. Notice how the y is being replaced. Now, this eliminates the y variable. And so what I then do is if I multiply this out, I get minus 2x plus 16 is 21. I then have 3x minus 2x is x plus 16 is 21. And then if I take away 16 from both sides, I should get x is 5. Now, can you remember how I found the y value that went with it? So what I did was I took the x is 5 value and I plugged it back into the easiest equation. And I'm going to say that the easiest equation is this one over here. And so if I use this, I'm going to say y is equal to minus whatever x is plus 8. And since x was 5, my y value should be minus 5 plus 8, which is 3. So the intersection point of these two straight lines is going to be 5, 3. Now, what I want is I want to finish this lesson with this last question on intersection points here. at the very bottom, I want you to find me the intersection points of these two straight lines. The one straight line is already in lovely standard form. The other straight line is not in standard form. And I want you to try and use the process I've been showing you, which is you take one of the equations, the easy one, and you substitute it into the harder one to help you. Okay, so while those who are feeling comfortable working ahead, I'm going to explain the example I just did again, just to try and show you the process I went through. And then the rest, those who are feeling comfortable can get on with this final example. So whenever you are looking for the intersection point of two straight lines, you have to solve the two equations simultaneously. Now, what does that even mean? Well, we're looking for an x and y value that make both these equations true at the same time. But on a procedure level, it means looking at the two equations and seeing which of the two are easiest. And if I look at this example here, the easiest equation is definitely this one. So I want to sub this equation, x plus y equals 8, I want to sub it into this one here. Now, before I can substitute one of them into another one, I need to make it to be in standard form, or a form where the y is by itself. And so that's why when I went from purple to yellow, I got the y by itself. I just moved the x across. Then the next line I want you to look at is this line, where I'm working with, I'm literally subbing into that equation, and then I solve for x. Once I've solved for x, I then have to find what y is, and the way I find y is using the original equation. So I hope that helps a little bit. I will stay online a little bit now extra to help those students who are struggling, but I just want to go through this last example here before we finish the lesson. So of these two equations, which is the easier one? I think I make that equation 1, I'll make this equation 2. The good news is it's in standard form as it is. And so when I substitute it into this other one, I like to write this out where I leave an open space for where I'm substituting in. So I'm taking this one. It's going to be 2x plus 1. Now I've done what's called the substitution step. But now I need to do the cleaning up step. And the cleaning up step is to multiply this 2 and that 2. So we get 4x plus 2 plus 3 is 0. And now we look for like terms. So these are like terms. So we get 5x plus 5 is 0, because it's like this. If I take away 5 from both sides, I get 5x equals minus 5. If I then divide both sides by 5, I should get x is minus 1. Now, that question, unfortunately, is not finished because I need an intersection point. So what I want to do is I want to take this x is minus 1 and I want to use this equation to help me. And what I'm going to do is I'm going to say y is equal to 2 times something plus 1. That something is the minus 1 down here. And so then y is equal to minus 2 plus 1. Okay, now be careful. I can see this is going to catch some of you. What's minus 2 plus 1? Minus 2 plus 1 is actually just minus 1. And I think that caught quite a few people. So let's go over that one more time. We got x is minus 1. But when we substitute it back into the original equation, 2 times minus 1 gives me minus 2. Minus 2 plus 1 gives me minus 1. And so my intersection point is going to be minus 1, minus 1. And we can check this by just substituting this point into any of the two equations. If it doesn't make the equation true, then something has gone wrong. And you'll see if you put minus 1 into these two lines, it makes true statements. Okay, now that was quite a lot of work that we did there. So let me just go over the process. When you are finding intersection points, when you're given two straight lines, the way you find intersection points is by solving the equations simultaneously, which means substituting one into the other, normally the easy one into the hard one. You then find one of the intersection point parts. The part in this case that we've found most of the time has been x. Once you've got that x, you substitute it back into the original equation, but the easy one, and then you can get your y value. And then the x and y that you found is basically the place where these two straight lines are meeting on the graph. Okay, don't worry. Again, we're going to practice this again. This is a key skill, though, that does come up a lot. So just to end the lesson with an easier question, let's end with a final one here. So what is the answer to this multiple choice question here? You can finish with a nice feeling. So according to the graph, what are the solutions to the simultaneous equations or the intersection points for this graph? We'll finish with that. And then while you're doing that, I'm also going to put a poll out just about the lesson pace. So if we look here, the intersection point to me looks like 2, 1, which would be A. If we went through the algebra, if I'd given you the equations of the two lines, you would have solved them simultaneously, just like we've done there. But I can see all of you guys are just about getting it. And yeah, please fill in the poll, guys, just so that we get a sense of how things are going for you. I just want to get a feel for the class. Obviously, there's no perfect speed, but we try and keep track and make adjustments as we go. And then, yeah, for any students who have an additional question, I will stay on the line for a moment or two. But those who are finished and have answered the poll, I'm bringing the lesson to a close. Thank you, Yolanda, for your help in the chat and in the background. It was very good.
Thank you.
Yeah, and I'll just give a moment or two for students to help us if they are not help us ask their question if they do have a question. Put your hand up.
While they're busy putting their hand, as a reminder, remember about the information that we have given at the beginning of the session. So if you do want to be part of the exam preparation, please make sure you do speak to your parents.
Yeah,
thank you.
It's an important one. Notile, go ahead. What is your question?
So I wanted to ask if when the exam preparation class is going to start, which Saturday specifically?
This Saturday. So it's the 14th and the 21st, because we did a survey a couple of weeks back. We asked students when most of them are starting exams. And so it's based around that survey that we did.
Okay, sir.
Cool. Younger, what is your question? Go ahead, Younger. Kitty Bonner, okay, Younger, is that Kitty Bonner? What is your question?
So I wanted to ask how long are the extra lessons?
The exam preparation is an hour and a half. And what we're going to do in the one session is we're going to do paper 1 questions. So like equations and inequalities, exponents, functions, that type of thing. And then in the paper 2 revision session, based on what students have covered, we'll do more trigonometry, circle geometry, that type of thing.
Okay, thank you, sir. Good night.
Pleasure, man. All right. I think that is it. Oh, Bochlale, go ahead. Ask your question.
So on Saturday, can we do the nature of roots?
The nature of roots. I'll definitely, if we're doing past papers, there will always be a little bit on the nature of roots and delta. And so we'll try and put some of that into the exam preparation stuff. Yeah, I'm sure we can do that. Yeah.
Thank you, sir.
Cool. A Bongwe?
Sir, can I ask, when you find the points for the gradients, how do you determine which one is Y2 and Y1?
Okay, the good news is, there's a lovely answer for this. It doesn't matter as long as you're consistent, right? So if I have 2 points, so like 2, 3, and 4, 5, it doesn't matter which point I start with as long as I'm consistent. I generally take Y2 as the one that's furthest to the right. So whenever you see me doing this, I tend to just go 5 minus 3, and I do the Y first, because I know if I'm tired, I'll make a silly mistake and put the Y on the bottom. And then I do my X second, which is 4, say for example here, 4 minus 2. Now, would it have mattered if I started the other way around? No, but I would have to then have been consistent. So that would be, if I'd done it that way, I then would have gone 3 minus 5, and then 2 minus 4. And it gives you the same answer. Yeah.
Okay, sir, thank you.
Cool. All right. I think that is it. And so what we will do is, I think, call it a night. But yeah, thank you, everyone. And it's been good. And best of luck with the school.